In this math talk, we introduce the concept of a greatest common factor. And in this case, we start with the question, find the greatest common factor, also known as the GCF, for 42 and 70. And in fact, before we even get started on that, I'm going to look at the greatest common factor for two smaller numbers, and I want to explain what a greatest common factor is. In the case of 42 and 70, the greatest common factor is the largest natural number that we can find that divides evenly into 42 and into 70. And when I say divide evenly, I mean divide without any remainder. So let me pick a simpler example. If I were to look at, say, the numbers 6 and 8, and I were to consider all the factors of 6, well, we know from previous videos that numbers fall into the category of composite or prime. 6 is clearly composite simply because it's even and it's greater than 2, and 2 is our only even prime. So in fact, all of the numbers, all of the factors of 6, or all of the numbers that divide evenly into 6, are 1 with a 6 and 2 with a 3. So in fact, my factors are these: 1, 2, 3, and 6. All of those numbers divide evenly into 6. When I look at 8, it has factors of 1 with 8. 1 times 8 gives me 8, as well as 2 times 4. So my factors of 8 are 1, 2, 4, and 8. Now, if I'm trying to identify the greatest common factor at this point, the greatest common factor would be the 2 that appears here and here. In other words, 6 is divisible by 2, evenly divisible. 2 fits in there 3 times. 8 is evenly divisible by 2, and so that works out to 4. Neither of those have a remainder. So our greatest common factor, our GCF, is 2. Now, as you look at our original question, which is find the greatest common factor for 42 and 70, you realize that this might take a little bit longer simply because there are a lot more numbers that divide into 42 and 70. And so we have another strategy which builds on one of our earlier videos, and that involves prime factorization. So let me show you what I would do to answer this question. I would take 42 and I would break it into its prime factors. In other words, perform a prime factorization. Well, 42 is 6 multiplied by 7, 6 times 7. The 7's prime, the 6 is composite, and so it factors further into a 2 and a 3. Bringing the 7 down, we now have our prime factorization. 2, 3, and 7 are all prime. I will continue the process with 70. So I look at 70, and I'm going to split that down into 2 factors. We'll make it probably the easiest. It's 7 and 10, so it's 7 times 10. 7 is prime. The 10 composite, so it can be broken down into 5 times 2. So we have 7 times 5 times 2 giving us the 70, and 2 times 3 times 7 giving us the 42. Now to find the greatest common factor, I just build it from the primes that they share. So my GCF, in this case, if I'm looking at the prime factors that each of these numbers share, they both share a 2, and they both share a 7. So my greatest common factor will be a 7 multiplied with a 2, or in this case, 14. Now let's check. If we take the 42 and we divide by the 14, we get an answer of 3. Now you may be wondering, how did I get that? How did I get that so quickly? Well, it's very simple. If I factor out from 42 that 2 and that 7 that build the greatest common factor, all that's left behind is that 3. So 42 divided by that 14 is 3. Let's check 70. 70 divided by 14. Well, once again, if you've factored out the 2 and the 7, all that would be left behind would be the 5. And so they're both evenly divisible by 14. So let's try this process with some larger numbers. Find the GCF for 135, 180, and 495. Now we're dealing with some very large numbers, but using the same strategy, we're going to build our GCF from the prime factors that all three numbers share. So I will begin with the 135. I know that that's divisible by 5 simply because it ends in a 5. And so I get 5 multiplied by 45. 5 is prime, 45 is composite, and so we get 5 multiplied by, I will split 45 into 5 times 9. We're getting closer. Both of these are now prime. And the 9 can be broken into 3 multiplied with 3. So for 135, we have 5 times 5 times 3 times 3. Moving on to the 180. 180 will factor into 18 times 10. That to me is the easiest way to begin. 18 factors into 9 times 2, and the 10 factors into 2 times 5. At that point, the 2 and the 5 are prime. The 2 is prime. We now just have to factor the 9. So that becomes 3 times 3. We have this 2. We have this 2. And we have this 5. So 180 factors to be 3 times 3 times 2 times 2 times 5. Finally, the 495. 495 factors to be, once again, it's divisible by 5. 5 times, in this case, it would be 99. 5 is prime. 99 factors to be 9 times 11. The 5 is prime. The 9 can be factored to be 3 times 3. And the 11 is prime. And so 495 is a 5 times a 3 times a 3 times an 11. So now let's identify the prime factors that the three numbers share. Well, I see a 5. I see a 5. I see a 5. So my GCF will have for sure a 5 in it. I also see a 3, in fact 2 of them here and here, here and here. So we have 2 3s in our greatest common factor as well. Now when I look at the remaining factors, they have nothing else in common. The 135 has a 5 left over, the 180 has 2 2s left over, and the 495 has an 11 left over. So we've got all of our common factors out of the three numbers. And so as we work out this greatest common factor, 5 times 3 times 3, 5 times 3 is 15, times 3 again is 45. So the greatest common factor, or the largest number that divides into 135, 180, 495 is 45. Basically, that's all there is to finding a greatest common factor, and I'm out of time.